This video will expand on the basic concepts that we talked about in the previous video. In the first video, we talked about a terminology called assignment. X equals 5 is an assignment. You assign values to variables. Here, I do x equals 5, and I am going to print out x, and I get 5. A variable can be assigned many times, and it always keeps the value of its most recent assignment. Here, x equals 5 because there's only one assignment. The most recent assignment is x equals 5. Now, if I do x equals 7, it replaces x equals 5. X equals 7 becomes the most recent assignment. And since I print out x, I get a 7 because x equals 7 is the most recent assignment. Now, because of this rule of most recent assignment, you can do things like x equals x plus 1, which adds 1 to its most recent assignment. Here, I'm writing x equals x plus 1. And x still contains its most recent assignment, which is 7. So the problem becomes x equals 7 plus 1. And here, we get 8. In the previous video, we also talked about functions. We used the print function and the type function. A reminder of what functions are. Functions are fancy terms for defining commands that we can use in Python. And Python comes with a lot of these pre-configured functions like print and type. When we use a specific function, it is called a function call. When I type parentheses 4 parentheses, I am calling that function type with a value of 4 to use. When calling a function, the value inside the parentheses, in this case 4, is called an argument. 4 is an argument of the function. All you need to know is that values inside the parentheses of functions are called arguments. That's the name that they're given. When I print out type parentheses 4, I get the value type int, which we print and display right here. Whenever a function call gives us a value, we call it the return value. Class int is our return value because we receive something. Using the type function, we expect the function to give us back the type of the value. And if the function gives us anything back, like class int, that value given back is called the return value. We've talked a bit about types so far. Sometimes you don't have the type that you want. For example, you could have this string, like fruits equals quote space apples quote. Before the word apples, perhaps you want to put a number like 5 to get 5 apples. However, you cannot combine an integer, a whole number like 5, with a string because they're not the same type. This is where types are important. And Python luckily has built-in functions that convert values from one type to another type. Here, we create a variable called num_fruits, and we use the str function called the string function that converts a value to string type. We can print out num_fruits to get 5 apples because str converts the number 5 to a string. And then we can use the plus operator to combine 5 with apples to get 5 space apples. There are also functions for the different types, like int parentheses, that converts a type to an integer if possible. For example, int parentheses quote 4 quote parentheses. 4 has quotation marks, so it's a string, but we know that that string is also a valid number, so we can use this int function to convert the string into an integer because it's a valid number. It's a valid whole number. And we can use print x here and we get 4. But that doesn't really tell you if it actually is an integer or not. So let us do type parentheses x and make sure that this string has converted to an int. As we can see, it's class int, short for integer. You can also use integers with floats. So there's a float function, and we can exchange int with float. And this string 4 will convert to a float. As we can see here, we run the program, and there it is, class float. because we use the float function. So we have str for string, int for integers, and float for floats. We've talked quite a bit about numeric types so far. I'm talking about integers and floats. You might be thinking, why not just have one type called number and make classifying numbers easier? Why do we have integers for exact whole numbers and floats for values with decimal point numbers? One reason is because of different behavior. Depending on your version of Python, the division operator works differently for float and integers. Here in Python 3.6, I can print out 1 divided by 2, and I get what I expected, 0.5, a half. Python 3.6 automatically gives the result of type float when expected. If I print the type out, it's going to be type float because 0.5, since it has numbers after the decimal point, is a type float. But that's not always the case. Let's say that I open up a new terminal, and I am going to open up Python 2.7 on this terminal window. Another version of Python, Python 2 for short. If I divide 1 by 2, the result is 0. Why is it 0? I'm going to do 1 divided by 2, and the result is going to be 0. When an integer is divided by an integer in Python 2, you will get an integer. In integers, if you have values after the decimal point, those numbers get automatically deleted. How do you fix this problem? Well, if I do 1.0 divided by 2.0, I get 0.5 as expected. Because a float divided by a float will get a float in Python 2. It's a little confusing. If you wanted to get an integer in Python 3 after dividing two integers, they implemented this thing where you use 2 backslashes. You can see I do 1 and then 2 backslashes for integer division with the 2 in Python 3, and I'll get 0. Because integers with numbers after decimal point will always delete all the numbers after decimal point. 0.5 becomes a 0 because the 0.5 gets deleted. As we saw with division, integers and floats can have different behaviors, but they also are represented differently too. I'm not just talking about, whole numbers are integers and floats are decimal point numbers. I'm talking about inside memory. We need to explain what exactly is a float. Floats are approximations of numbers. What does that mean? For a human being, it's easy to know that 1 divided by 10 is 0.1, a tenth. But Python stores floats inside memories only through ones and zeros, the binary numbers. With binary numbers, you can't represent 0.1 exactly. It's actually represented as this gigantic approximation. Look at this. It's this huge approximation. But when we print out 0.1, Python knows, hey, 0.1? Okay, I'll round this down to 0.1 and not show this giant approximation that will confuse the human. So we can print out 0.1 or 1 divided by 10, and we'll always get 0.1, but just know that it's never an exact 0.1. It's an approximation inside memory. Now, this complicates things when it comes to addition. You're dealing with approximations and adding with approximations. So we have 0.1 plus 0.2, and then you get an approximation. We know as a human being that 0.1 plus 0.2 is 0.3, but Python, because of how floats are stored in memory, when I print 0.1 plus 0.2, it becomes this 0.3, and then a 4 eventually. Next thing that we'll talk about are imports. Python has this thing called modules. Modules are just a fancy term for a package of pre-configured functions. You can import a module by typing import space module. One such module is math, so we typically put modules at the top of the program, and I'll leave import space math at the top. This module comes with a bunch of pre-configured functions, but we'll use square root. Math.square root, parentheses. To use a module's functions, you always follow this pattern. You type the module name, then a dot, and then the function. For example, x equals math.square root, sqrt, parentheses 4. And when we print out x, it gives us a 2. Functions like print and type come usable with Python, but Python doesn't expect everyone to want all the pre-configured functions. So Python expects you to import them. And whenever you're using a different module or you want to see if Python has a module, I recommend you to Google to find out what a module can do. I can Google math module in Python and find out all the functions that the math module can do. And we can find the function of the math module that we just used, sqrt square root. And we see it here, math.sqrt, and put a value inside the parentheses. We talked a lot about these pre-configured functions that come with Python and its modules, but what about adding our own functions? Specific commands that will do what we want them to do. We need to define a function, or in other words, create our own function. The layout of a function in Python goes like this. You type in def, then space, name of the function, then a pair of parentheses with variables inside them, then colon, and then enter, and then put your statements, each on a new line. Def is short for definition. The function definition starts all the way from the left side. Then the statements below that function definition must be tabbed once to the right. The tab is how Python knows that, these statements are part of the function. So if the user wants to run the function, do all the things below that are tabbed once right. You can name the function anything that you want, except the same rules for naming variables apply to naming functions. Values inside the definition of a function are called parameters. Where I put variables, those are parameters. Parameters are just another one of those fancy terms used for defining that the function expects variables inside the parentheses. Now, we can do something like a print parentheses 4, and earlier in the video, I said that 4 was an argument. Well, what's the difference between a parameter and an argument? When we make a function definition, the variable is called a parameter. But when we use a function and there is a value inside the parentheses, that's called an argument. Let's say that we were creating a new function called print_number. So we follow that layout, def, and then name of the function, put in parentheses, put in the variable names, and then put our statements below the function. So here, print number takes in a number, and we follow the same layout. You have the def, you have the name of the function, you have the pair of parentheses, the parameters, which are just variables. These are just variable names. And then make sure you have that colon. Then you tab once and put all your statements. Here, this function that I created just prints out the variable, prints out the number. Now, the variable number is called a parameter, but when we use our function print_number parentheses 4, the 4 inside the parentheses is called an argument because we're using the function. The word parameter is used for the value in creating the function definition. The word argument is used for the value in using the function. Number is a parameter, and 4 is an argument. Create a function versus use a function. Parameter versus argument. You'll see all of these terms often in the future, so it's useful to understand the difference, even though the terminology can confuse you sometimes. You'll get the hang of it. Let's do another example. Let's say that we wanted a function, a command that printed the first 3 letters of the alphabet, each on a new line. We'll call it alphabet. Now let me delete all this stuff and use the layout. First, you have to type def all the way from the left side, space, the name of the function, which is alphabet, a pair of parentheses, colon, enter, do one tab, print A, do another tab, print B, and then do a new line, tab, print C. You can see that all the statements have a tab, but most importantly, you see that I didn't put any parameters. Parameters are optional. Empty parentheses means that there are no parameters. I can type alphabet with nothing inside it except for the parentheses and run the program. And we'll see that it will print A, B, and C, each on a new line. Now, we can use functions that call or use other functions. Let's say that we want to print the first 3 letters of the alphabet 3 times. Let me delete this alphabet and make a new function called print_3_alphabets with a pair of empty parentheses, and we will call our alphabet function that we just made, and we will do it 3 times. You can see all functions have the same layout with the DEF, and I can call alphabet from within this new function. And we can run print underscore 3 underscore alphabets, and the function uses our alphabet function 3 times, and each time alphabet function runs, it's 1 by 1. We'll see over here that when I run the program, it's ABC, and then ABC, and then ABC. All of these ABCs are each a separate execution of that function. The most important reason why we create our functions is to make our program smaller by reducing repetitions. We can have a repetitive action in a single line of Python if we create a function. For the functions that we've used so far, they only require at most one value, one argument. If you want to display the number 4, all you have to do is write print parentheses 4. Just print with one argument. You can create functions with multiple parameters. Let's say that we want a function to display the number of animals a person had. Print underscore num underscore animals. For each parameter, if there's more than one, you separate them by commas with a space. Now inside this function, we're also going to combine it with some of the other concepts that we've learned. We're going to print 2 space dogs. So first we have a number, but that number needs to be a string because we're combining that number with some strings. So we used num string variable where it's equal to str parentheses number. And then num underscore animals is num underscore string plus a space plus the animal, which the animal we'll assume will be dogs. And then let's print num underscore animals, which will print us the string, which should be 2 dogs. So how we run and use this function, we'll type in print underscore num underscore animals, parentheses, the number, which for an example, we'll just use 2, comma, then in quotes, we'll put in dog, end quote, then end parentheses. And here, 2 is a number. So 2 gets carried as a number, and then we convert it in string in the function. Then dogs is just animal. And for the arguments, you separate by commas, just like how the parameters are separated. If you have more than one parameter or argument, you separate them by comma. And you get 2 dogs. That's how functions with multiple parameters works. Let's talk about the order of execution or flow. What's the order of things run inside a Python script? When you see the function definition with DEF and the typical bunch of statements below the definition, the function won't execute unless you use the function. I just deleted print underscore num underscore animals, and since I never called the function, nothing happens. The function definition is merely a definition. It's not using that function at all. You need to define a function and write that function definition before using it. For instance, I can put the function call before the definition, and this is going to error out. I can put print underscore num underscore animals and call the function, and this will error out. Because in Python, statements are executed in order, starting from line 1, going line by line, until it reaches the end of the program. Here I get the error name print underscore num underscore animals is not defined. Python is computed line by line in order. If you had a lot of errors in your program, Python would look at your program, compute the first line, keep on going line by line, one by one, until it finds your first error, and then stop. If you had multiple errors, then Python would just stop at the first error until you fix the first error in the line of execution. The last thing that we'll talk about in this video is the concept of local variables. What do local variables mean? When we declare variables, we've seen that we can use variables the same way that we use values, because the variables are equivalent to the values that we've assigned. I can do x equals 5 and print it out, run the program, and 5 would be displayed. Nothing special over there. But when variables are assigned inside a function, the variables belong to that function. The variables are local to that function. I can create a quick test function. Test underscore function, put x equals 5, print out x, and x belongs to test underscore function. They cannot be used outside of that function. That's where we get the term local variable. When I do print parentheses x parentheses outside of function, it's not going to work because x belongs to test underscore function. It's only local inside test underscore function. And I get this error, x is not defined, because it doesn't know what x is. X belongs to test underscore function, and we didn't call test underscore function, so there is no x. Python thinks, oh, there's no x, because there's no x in this area. Hope you liked this video. More to come next week.